JRuby is a polished and stable Ruby implementation built upon the Java virtual machine. Now, I'm not much of a Java guy myself, but I think JRuby has a lot to offer whether you use Java frequently or not. In this episode, I'll show you the basics of setting up JRuby and focus on some areas where it differs from Ruby MRI. Well, let's get started. One option is to download and install it through the package provided on the site. However, my preference is to install it through some kind of Ruby environment manager, such as RVM or RubyEnv. I'll use RubyEnv here with RubyEnv install, and then JRuby, let's do version 1.7.0 preview 2. Alright, so that's installed. So this is the most recent release at the time of this recording, but a newer version might be out by the time you watch this. Next, I'll switch to that version for this shell, JRuby 7.0 preview 2. Now let me check the version of Ruby here just to make sure it switched correctly, and it did. And depending on your installation setup, you might need to prefix Ruby-based commands with J to make sure that they're using JRuby. Same with IRB, but in my specific installation here, that isn't necessary. It will use a JRuby each time. So let's do some experimenting here in IRB to see what sets JRuby apart. Now I can run Ruby commands just as if I'm in MRI 193, and for the most part I won't notice much difference. However, one of the biggest changes is that I have access to the entire world of Java and the many libraries it provides. The key to unlocking this is this line right here, require Java. This allows me to access various Java classes, let's say a hash map. I'll instantiate a new one here, and we can put a value into here, let's say set bar to foo, and then get that value back out. Now in core classes like this, JRuby provides some convenience methods beyond what is provided by the Java interface. You can see here we can access values similar to how we would a hash in Ruby. We could even iterate over it and much more, even though this is a basic hash map in Java. Now let me show you another example that's quite a bit more interesting, and that is Swing. This allows you to create a graphical user interface. So let me open up a option pane here and tell it to show a message dialog, and let's say hello world inside of it. And there we go, there's that dialog. So we can create full-featured UIs with this. Not all that useful in a Rails app, but really handy if you're creating administrative scripts or something. Now JRuby gives us an alternative way to access this which closer matches a Ruby style, and we can access the class through a Java namespace and then provide the package, so that is JavaX Swing, and then the class name JOptionPane. And then the showMessageDialog method, we can call it through underscores instead of using camel case. So showMessageDialog, and then let's try this out, passing it hello. And there's that same dialog box, just in a different code style. Now let me show you a fuller example of what's possible with Swing. I'll create a new file here, let's call it swing.rb. Now I'm just going to paste some code into here, but let me walk you through it. I'm calling require Java at the top like we did in IRB to give us access to Swing. And notice I'm calling Java import to import various classes so we don't have to always go through the package when we need to access them. This way we can access the classes directly throughout the rest of the script. And also notice I'm creating a new class called Hello World and inheriting from JFrame, which is a Java class. So that's pretty cool. You're able to create a Ruby class that inherits from a Java class. So this will end up creating a window in my interface, and here I set the size and a few other properties. And I also create a new button and add it to the window. So this has the title of Say Hello, and when the button gets clicked, this block will be triggered. So I think in Java you would use like an anonymous function or something, but here in Ruby we can conveniently use a block when that button gets clicked. And here I'll just show a message dialog, and then we open up the window, and I instantiate the class here. So let's try running this through the Ruby command. Again, you might need to use the JRuby command on other installs. So it's called swing.rb, and that opens up this window with a button called Say Hello. Clicking on it shows that message dialog. It works. Now having such a great bridge between Ruby and Java can be quite useful, but me as a Rails developer who rarely uses Java, I don't find much need for it. However, what really interests me about JRuby is its improved support for concurrency with threads. Let me give you an example of what I mean by making a new Ruby script here. Now I'm just going to paste in the code for this script. This includes a simple Fibonacci method, which will just give us something to calculate, and I'm going to trigger this method 5 times, each in a separate thread. And so this is just going to grab the Fibonacci number for 32, which will take a little while, and after all of those threads are done processing, I'm just going to print out the total time it took to run. So let's run this on JRuby and see how well it works. So I'll pass that script in to the Ruby command, and this takes about a half a second to process. Now let's see how this compares to Ruby MRI. I'll switch to 193. And then running that same script again, this time it takes a considerable longer period of time. So that took about 3.5 seconds. That's nearly 7 times longer than when I ran the script in JRuby. Now the main reason for this slowdown is due to the global interpreter lock. I recommend you check out this article by Matt A. Minetti, who goes into further detail than what I'll be covering here. Basically, the global interpreter lock prevents this Fibonacci sequence to be fully run concurrently on the separate threads. Now if you have a multi-core machine like I do here, this time difference will be really noticeable. However, what if you're not constantly processing Ruby? Perhaps you're waiting on the database or the file system. In most of those cases, the global interpreter lock will be lifted, so let's simulate this with a sleep call. So I'll just sleep for half a second here. And now when I run the same script in Ruby MRI, you can see it only took a half a second because the lock is not set when we're just sleeping. Now let's say you're building a multi-threaded Rails application and you're wondering how performance might change if you switch to JRuby due to this concurrency difference. Well, that'll depend greatly upon how much time your Rails app spends accessing the database versus executing the Ruby code, and also how many cores are on the machine. Now, of course, there are many other things you should consider when comparing performance, but in general, if you're setting up a multi-threaded Rails app in production under MRI, you'll probably still want to set up separate processes running the Rails app to take full advantage of concurrency, whereas in JRuby, you can handle everything all in a single process. Now, I'm going to finish up this episode by showing you how to make a Rails application compatible with JRuby. First, I'll switch over to JRuby, then I'm going to install Rails and make sure we have the latest version. So with that installed, I'll generate a new Rails app. Now the Rails generator is quite smart and it will automatically make it compatible with JRuby if we make a new app while running JRuby. There we go. Now let's open it up and take a look. Now the key differences are inside of the gem file. The first one is right here. Instead of having a simple SQLite 3 gem, we have this active record JDBC SQLite 3 adapter gem. Now JDBC stands for Java Database Connectivity and is a standard way for Java to communicate with a database. And so this gem takes advantage of that and adapts active record to using JDBC. Now it's important to understand that some gems are incompatible with JRuby because they rely on C extensions. The SQLite 3 gem is one of them. We can see this if we try to install the SQLite 3 gem. Once it gets to trying to compile the native C extension, then it's going to run into some problems and it's going to give us an error. There it is. Now there are some ways to get around this problem, but it's really best to look for an alternative gem that is compatible with JRuby. The JRuby wiki has a nice page on C extension alternatives, which is a good place to go if you're using a gem which has a C extension and are looking for an alternative option, and several gems are listed here. Also, check out the JRuby lint gem. This provides a command which you can run in your project to see if there are any incompatibilities with JRuby. This doesn't check everything, but it does include a look for C extensions and a few other things. Going back to our Rails app, the next gem mentioned here is JRuby OpenSSL, which emulates Ruby's native OpenSSL library. And then the only other gem that's added here, especially for JRuby, is the Ruby Rhino, which is used to execute JavaScript. So if you're converting an existing Rails app over to JRuby, add in these 3 gems to make it compatible. And from here, you can just continue working on your Rails application like you normally would. I'll generate some scaffolding here for an article just to give an example, and then I'll migrate the database. And then I'll start it up. Now visiting localhost port 3000/articles takes us to the scaffolding page where everything works as we expect. Now you may notice that loading in the entire Rails application in JRuby can take quite a while. You can see this took about 32 seconds to execute this Rails runner command. In general, JRuby is much slower at loading code initially, but is quite fast once it's loaded in. If you're struggling with this, you may want to consider making your application compatible with both MRI and JRuby, so that way you can occasionally use MRI in development when you're frequently needing to load the application. You can accomplish this by going to your gem file and adding a call to platform to only load certain gems for a given Ruby implementation. So we can pass in JRuby here in a block, and this way those gems will not be used when you're using MRI in your application. So let's pass in a group to assets for the Ruby Rhino gem here, and then clear it out as well. Oh, and then it's also necessary to add a platform for just plain Ruby, and let's add the SQLite 3 gem into there. Now if I switch over to Ruby MRI 193 and then run the bundle command to install the gems, And then starting up the server, our Rails application will work with both MRI and JRuby. We can see that by reloading this page, and it works fine. If you do this, it's a good idea to have a comprehensive test suite so you can ensure it works in both JRuby and MRI. Well, that's it for this episode on the basics of JRuby. Thanks for watching. In the Pro episode this week, I covered deploying a JRuby application using Trinidad. There I show how to set up a Capistrano recipe for automated deployment, along with some of the various configuration options. To watch that episode and gain access to all previous Pro and revised episodes, visit railscast.com/pro, and you can sign up there for just $9 per month. Several years ago, I participated in the Rails Rumble contest and submitted this app called Daily Stamp. The way this works is you enter in something you want to accomplish daily, let's say contribute to open source and then get started. And then this presents you with a calendar and a stamper which you can use to stamp any day which you accomplish this task. Now what I want to focus on in this episode is the ability to customize a stamp. So here you can change the image icon or add your own stamp icon. And what better image to use than a picture of GitHub's Octocat? You can see here it's in full color. And so let me choose this and upload that. So this turns it into a stamp looking icon, and there are several different colors that are provided as well, so we can choose a given color and submit it. So now this becomes the stamp displayed on the calendar, and what I want to show you here in this episode is how you can perform the same image manipulation to convert one image into something that looks like this. A key ingredient here is ImageMagick. I have a love-hate relationship with this. It's a pain to set up and use, but once you figure it out, it's quite powerful. And if you're wanting to do extensive image manipulation, this can take you pretty far. Now a good place to start are the command line tools. This will give you an idea of what ImageMagick is capable of and what steps are involved in processing your image through it. Installation can be a little tricky. If you're on Mac OS X, I highly recommend installing through Homebrew with brew install ImageMagick. So this should give you access to the convert command along with several others for processing the images. And the version I'm using here of ImageMagick is 675. Now in addition to the source image, which is what I'll be converting, I have this other image which is sort of an overlay texture. It's a little bit difficult to see here, but it's basically just a white image with some transparency to give it a stamp looking texture. Now my first objective is to resize and crop the source image so that it composites nicely with this overlay texture. Now if you check out the documentation for the convert command, you can see a list of options which can be passed in, including options to crop or resize the image. And both of those options accept this geometry parameter, which we can get further documentation on here. So this tells us different ways that we can format the argument to change its behavior. And this is really handy if you're trying to make a square thumbnail like we are when you have an oddly shaped aspect ratio image. The one I'll be using here is this caret symbol, which will allow me to fill the stamp image while maintaining the image's aspect ratio. So let's do this. I'm going to run the convert command on the Octocat image and resize this to 70 by 70 pixels. I'll use the caret symbol there. And also I want to crop it to that same dimensions, but for cropping I also want to supply the offset value, which will just be 0. And I'll just save this as a source.png image. And by the way, ImageMagick is really good about choosing the format, so if we just do a JPEG image here, then it will automatically handle the conversion, but I'll keep this as a ping. So here's the resulting image. The dimensions are right, but notice that it's off-center. I want it to crop in the middle instead. This can be accomplished through a gravity option, which I can set before the crop option, just set gravity, and then set this to center, which will instruct it to keep it centered as it's cropping it. There we go, that looks much better. So already we have a nice command we can use to turn any image into a thumbnail. But I want to go further. Let's turn this into a grayscale image and add some contrast so that it can easily be converted into a stamp. We can accomplish all of this by passing in a few more options. Quantize will be used to set the color palette, and we can set it to a grayscale. By the way, I found the casing to be important there. And then we can add a colors option to do the actual conversion. I'll set it to 256 colors. And then I'll add a contrast option to make it pop a little more. There we go, we now have a grayscale image. Now it's time to composite the overlay on top of it so it'll give it a stamp texture. We can do this easily enough by using the composite command to overlay one image on top of the other. So I want to composite the stamp overlay image onto the source image, and the output should just be the source image, so I'm just going to overwrite that image. There we go. Now we have that stamp texture overlaid on top. The next thing I want to do is add some color. Now, not only can the convert command be used to process existing images, but you can also use it to create images from scratch. So let's make a new image with a size of 70 by 70 pixels, and I want to color it red, so I can do that by passing in the canvas option and setting that to red. Now you can also pass in an RGB or hexadecimal value here instead of a named color, and also I found it necessary in some versions of ImageMagick to use a CX option instead of a canvas option, so keep that in mind if you do run into errors here. Alright, so let's save this to an image called color.ping. So this generated a colored image which we can composite with the source image. But instead of managing yet another file, I'm going to delete this colored image because we can handle the compositing in the same convert command. So here's how this works. I'm going to load in the source image, and then I can configure how it should be composed with the other one. I'm going to use the copy opacity composition setting, and you'll see the effect in a minute, and then I'll tell it to composite this. And then I'll generate a new file, let's call it stamp.ping. And there's that generated image. It's so close, but it looks like we need to invert the source image. We can do that by passing in parentheses when we load in the image, and those need to be escaped. And then I can pass in a negate option to tell it to invert the colors on that source image when it loads it in. There we go. Now our stamp image looks correct, and it would be very easy to configure our command to change the colors for the different stamps. Once you have this figured out, you can merge the entire thing into one convert command. It's a little bit long and hairy, but hey, it works. And you can see the output here looks the same. Now the question is, how do we get this functionality into our Rails app? Well, one option is just to execute this command from within Ruby, and that's not such a bad idea. There are a couple of gems available to do just this. Image sorcery is a thin wrapper around the command line tools. Another one that does something similar is MiniMagick. However, I found the interface to both of these gems to be a little bit cumbersome when dealing with extensive image manipulation. I'd probably just stick with keeping the whole command in a string and executing it through that. And then of course we have the classic RMagick gem. This hasn't been updated recently and some criticize it for leaking memory, but I've had great success with it, and I think it's a valid option if you're looking for an alternative to the command line interface. This wraps the C library, so the interface won't always be a one-to-one mapping with the command line, but it has a pretty decent user guide with some nice documentation to check out. So let's see what's involved in using RMagick to generate the same stamp image. First I'll gem install RMagick to get the latest version. Now I like to get the image manipulation working in a simple Ruby script before I actually move it over to my Rails app, so I'll make a new stamp RB script. First I'll require RMagick, and then I want to load in the source image, which I can do with magic image.read. Then I'll use that octocat ping, and then this returns an array of layer images, so I'm going to read, or actually fetch the first image from that. Now there's a very handy method called resize to fill, which basically does the cropping and resizing behavior that I did in the command line. And then we can call quantize on this to convert it to a grayscale. And in here I can say 256 colors and to use the magic gray color space. And you can check out the documentation for details on these arguments you can pass into these methods. So I'll say I want to also add contrast to it, and passing true here will add contrast instead of removing it. So this returns a new image record, which I'm just going to reset to that same variable. Next I want to composite the overlay image, so I'll first fetch that, and that's at called stamp overlay.ping. So then I can call source.composite with a bang to make it in place, and that's the overlay image at zero dimensions, and then I want to perform a over composite operation on it. So that will end up overlaying the image onto the source. Next I want to make a new colored image. I can do with magic image.new and then pass in the dimensions, and then a block in here, and that will allow me to change some settings such as the background color. I can set that to red. And then I want to composite onto this colored image the source image, but first I'll call negate on it to reverse the colors and set the dimensions to 0, and the operation should be copy opacity, which is what we did in the command line. And then I can just write this out to stamp.ping. That's it. So this will do basically the same thing we did through the command line. Let's try it out. So I'll run the stamp.rb script. So here's the generated stamp ping image, and it looks correct. So for comparison, here are what the two different approaches look like. If you're using the command line approach, just be sure to watch out for a shell injection if you're accepting user parameters. Using RMagic here feels more verbose, but it's also more dynamic. Just watch out for potential memory leaks. Now off camera, I built this simple Rails app to demonstrate adding this functionality in, and so we can just upload a file here, and then create a stamp, and then it generates a stamp image like we did before. Now let me briefly walk you through the code. I decided to use RMagic for this example, along with Carrier Wave to handle the upload, so I added these two gems to my gem file, and you can learn more about Carrier Wave in episode 253. And then next I have this stamp model, which simply mounts a Carrier Wave uploader called a stamp uploader, and here's what that looks like. So this is pretty standard except for the processing code down here. This is all that's needed to handle the stamp version, so what I did is loop through a variety of different colors, and for each one I made a different version in Carrier Wave of that image, and to generate that version I just processed the stamp method here and passed in that given color. So this calls manipulate, which is a custom Carrier Wave method, and telling it I want to use RMagic and generate a ping formatted image, and so that will pass in the source image and expect me to return the image I want it to generate. So this is basically the same code I used earlier with a couple variables thrown in. By the way, you'd probably want to move this off into some kind of background process, but that's a bit out of the scope of this episode. Now since each color is a different version, I can easily change the color that's rendered out in the view template by passing in a different version. And there we go. We now have some pretty extensive image manipulation done through our Rails app. Well, that's it for this episode. I hope you found it useful. In this week's Pro episode, I will show you how to use Monet to ensure your Rails application stays up and running smoothly. I will also show how to keep tabs on it so you can be alerted if something goes wrong. To watch that episode and gain access to all previous Pro and revised episodes, visit railscast.com/pro, and you can sign up there for just $9 per month.